Before I finish putting this head together and putting it back on the block, I want to talk about a few misfire related topics that don't really come up that much anymore. You know, some of these things are just forgotten about, lost to history, but you know, your misfire typically starts with compression, spark, plugs, coils, wires, you know, and then you got fuel, delivery, pressure. But you know, I want to talk about specifically here what causes a hole, one specific hole in misfire more than others. So say you got, well, say this engine's together and it has a misfire in this cylinder. So we can see here that sometime in the past, this thing's dropped a valve seat and somebody's replaced it, you know, and these are HO head castings. So these things are made out of pure unobtainium. So this is actually a really common thing, you know, especially with the whole 3.7, 4.7, 5.7 series Chrysler engines, and then like the Ford CVH, you know, like the 1.9 and split port motor like this one down here. Big valve seat problems. That's because the valves are really big, you know, compared to a 16 valve high revving, you know, no torque making Honda race car engine. You know, you got one big ass valve that weighs a lot, that gives you a lot more flow than you do with, you know, two little valves. But the thing about this is, you know, it's heavier, so you can't spin it as fast. But the problem here that we run into is vehicle presents with a misfire. So what do? You pull out the spark plug. Okay, spark plugs look good. Okay, so you rotate this spark plug to this hole. You take the coil from this hole and put it in an adjacent hole. You run it. What happens? Well, misfire stays in this hole. Okay, so it's not the spark plugs or the coil. So you can do, you know, compression test. You can rotate injectors. You can do leak down tests. But so compared to say this hole and this hole, if you do a compression test, these are going to give you, you know, pretty much the same reading. You might have a little bit less in this one, but you know, not much. So you could do a leak down test and you might find, you know, burnt up exhaust valves or loose guides, which is the scenario with this engine here. So unfortunately, your standard diagnostic testing isn't going to show that. Other things we got here are, you know, scoring on the piston in the cylinder, out of round cylinders. You know, we got rings like this one that's, you know, just totally frozen. So this could still pass a compression test, but it would give you a misfire because, you know, when it's firing all of that hot burning gas in there, it's going to give you a little bit more, you know, result than just doing a compression test. So one of the things that's lost to time is, you know, back in the early days of automotive, they didn't have hardened seats in here. The valves actually just sat right on the material of the head. So it was quite common and, you know, mandatory to do valve jobs on your cars, you know, every 10-15,000 miles. You know, that was just what you did. Well, with the advent of hardened seats, you know, these services are all but lost to time. Now we have much better materials, much better manufacturing. You know, 20 years ago, an engine or a vehicle lasting 100,000 miles, it was done. But now it's super common to see 200, 250, 300,000 miles on cars just because of the better quality materials. So when it comes to misfires, don't overlook mechanical failures. Now this, you know, these sticky rings, you're never going to be able to diagnostically test this by doing anything external. Same with this. You know, when this piston comes up here, the squish height is only about 40 thousandths between the piston and the head, and it's spaced out by the head gasket. So when this comes up really quick, you know, it creates a massive shock of pressure. And you know, some of these rough casting marks, you know, some of this crap in here, these could absolutely cause hot spots, which could cause misfires by pre-ignition, or, you know, just misfires because of flame propagation. So, you know, if all else fails, you know, you can stick a camera down in that hole and look to see, but you know, you're never going to find stuff like this, you know, with the camera. So I guess the point of all of this is, you know, when the basics fail, don't always throw away the fact that there could be a mechanical problem going on with your engine. And here's a case in point.